So for the empirical formula computations, you would need your periodic table and calculator when we solve for this. And we will tackle this first example today, and we will use the chart to make sure that every step is not skipped and every step has been accurately done. So the first example says, mercury forms a compound with chlorine that is 73.9% mercury and 26.1% of chlorine by mass. So we get the percentages of every element present. The question is, of course, what is the empirical formula of the compound that has been formed? So first step is we have to list down the elements present based from the word problem that we just read. So we have mercury and chlorine. When you write the element on the table, you write the symbol of mercury, which is Hg. Don't write the name, but we need the symbol. So mercury is Hg and chlorine is Cl. So that's what you need to do for the first column. The second column is we're going to put the percentages according to what is stipulated in the given word problem. So we have 73.9% mercury, so we just put that there, 73.9%. And then for chlorine, that's 26.1, so that's 26.1 right there. So after putting in place the given, so the first two columns are actually putting in place what are mentioned in the problem. Now we're going to start with our third column. So the third column is we are asked for the mass. For the mass of the certain percentage value that you got. Now to make this very easy, to get the mass, we assume that the sample is 100 grams. So if the whole sample is 100 grams, and remember that the total for the percentages will also be 100%, so therefore the mass will have the same value as the percentage given. So the mass here, if that is 73.9%, so the mass will also be 73.9 grams. Now you put the G value there. Similar to 26.1, so that will be 26.1 gram as well. So that's very easy for the third column because we just copy the value, but we instead put the gram unit for it to become a mass. Next, the fourth column is the mole. We're going to get the mole. Now there is an equation here how to get the mole. It's mass divided by the molar mass of the element. Where do we find the molar mass of the element? From the periodic table. So PT is periodic table. So you refer to the periodic table. So the mass is here. So I'm going to put that 73.9 grams over, so divided by is over the molar mass of mercury on the periodic table. Mercury on the periodic table is 200.59, and because that is molar mass, that should be grams per mole unit. So that's grams over grams per mole, and then you put the equal sign there. Okay, let me just put in place also the second element before we go to the calculator. So the mass is 26.1 gram divided by molar mass of chlorine on the periodic table is 35.45 grams per mole, and then you put an equal sign. So the units, obviously there will be a cancellation of units that will take place here because you're dividing grams over grams per mole. The G will cancel out, and also same thing here, so that the mole will be the unit that will be left for this particular calculation, and that's why it's called the mole step. We're getting the mole. So when you are ready and you put in place all your solutions, you're now ready to calculate it on the calculator. So it's just here, the first one is 73.9, so that's 73.9. Press first the one on top, then divided by 200.59 equals, so you'll see a lot of answers as well. So in this case, we will just get the first two decimal places again. So that's 0.3, and the 6 is followed by an 8. So therefore the 6 will become a 7. So that's 0.37 mole. And we will do the same for the second one. Second one is 26.1 divided by 35.45. So that's a lot of numbers as well. We're going to pick the first two decimal places. So that's 0.7, and the 3 is followed by a 6. So therefore the 3 becomes a 4. So that's 0.74 mole. And now we're good with getting the moles. Do we have any questions? If you are, please. If you don't have any questions, let's proceed to the fifth column, which is divide by the smallest mole. This can be a little confusing. What do you mean, Miss Narca? Or what does it mean by this, smallest mole? Now remember, the mole that we're talking about are the two moles that we got from here. So all you need to do is compare what you have here, 0.37 and 0.74. Which is smaller between the two? Of course, it's obvious that 0.37 is the smaller value. So what does this column mean? It means that all these mole values will be divided by the smaller value. So how does that look like? It's going to look like this. You write first your answer, 0.37 mole, then divide it by the smaller value between the two, which is also 0.37. So in this case, you are dividing it by itself. And that's how it looks like. And for the second one, you write first the mole here, and then divide it by the smaller mole, which is 0.37 mole. That's what it means actually, divide it by the smaller value from here. So obviously for the first one, it's being divided by itself. So the answer is just 1. 0.37 over 0.37 is 1. And for the second one, that's 0.74 divided by 0.37. That's equal to 2. It's already a whole number 2. So what we get here are already whole numbers. If it's already a whole number, that means we skip the next column, because it says here, skip this if it is already a whole number. So what we got here are whole numbers, so we don't do this. And so the simplest whole number ratio for our empirical formula are actually your answers for this part, which are 1 and 2, which will lead us to the final answer. What does it mean? It means that we have 1 Hg, so we write that as Hg1, and there are 2 chlorines, so Cl2. So to put this all together, our final answer for the empirical formula is just Hg, no need to write the 1 because it's a 1, that's our rule, and then Cl2. And that becomes our empirical formula for that substance. In other words, we're getting the subscripts, the subscript values of every element from the percentages that we got from the problem. And that is the entire chart steps for getting the empirical formula.